A shallow, gently sloping area of the ocean floor at the edge of a continent. Continental shelf. It is the underwater land around a continent that extends from the shore into the ocean. Imagine you're at the beach and you slowly wade into the water. It starts off shallow and gradually becomes deeper as you move further away from the shore. This gradual transition from shallow to deeper water is similar to how a continental shelf works, where the ocean floor starts at the edge of a continent and gently slopes downwards before dropping steeply into the deep ocean. Just like the beach, where the water is shallow near the shore before suddenly getting deeper, the continental shelf is that initial shallow area of the ocean floor before it plunges into the deep sea, making it like a natural extension of the land beneath the ocean. The movement of streams of ocean water. Ocean current. Ocean current is the continuous flow of water in the ocean, driven by wind, temperature, and salinity differences. Imagine trying to navigate through a crowded shopping mall during a big sale, where everyone seems to be moving in different directions, but there's a general flow guiding the crowd. This scenario is similar to the movement of ocean currents, which are like invisible paths in the water, guiding marine life and ships. Just as the flow of people in the mall is influenced by the layout of the store and the attractions drawing them in, ocean currents are shaped by factors like wind, the Earth's rotation, and the coastline, creating organized streams that direct water movement across the globe. The amount of salt dissolved in water. Salinity. It is the measure of how much salt is present in a given amount of water. Imagine trying to dissolve sugar into your morning coffee, but realizing there's just too much sugar for the amount of liquid in your cup. This is similar to the concept of salinity, where the focus is on how much salt is dissolved in a given amount of water. Just as the coffee can only hold a certain amount of sugar before it becomes oversaturated and leaves sugar undissolved, water can only dissolve a specific amount of salt before it reaches its salinity limit, highlighting the balance between the amount of solute, sugar or salt, and the solvent, coffee or water. A water current parallel to the shoreline. Longshore current. It is a movement of water that carries sand and sediment along the coast. Imagine trying to walk on a crowded sidewalk where everyone moves in the same direction as you, but slightly to the side, gradually nudging you along. This is similar to how a longshore current works, where the movement of water parallel to the shore slowly carries objects, like sand and debris, sideways along the coast. Just as the flow of the crowd influences your path on the sidewalk, the longshore current subtly shifts everything in its path parallel to the shoreline, guiding it along the coast, just like the crowd guides you along the street. The movement of sediment along a beach by waves. Longshore drift. Longshore drift is when waves move sand and pebbles along the shore in a zigzag pattern. Imagine trying to organize a messy pile of papers on your desk, but as you stack them, a gust of wind keeps shifting them sideways. This is similar to how longshore drift works, where waves constantly push sediment along the coastline in a particular direction. Just as the wind moves your papers sideways, the angled approach of waves causes sediment to shift parallel to the shore, illustrating how external forces can redirect a seemingly straightforward process. A swift current that flows from a sandbar to deeper water. Rip current. A rip current is a strong, narrow flow of water moving from the shore out to the ocean. Imagine trying to navigate a crowded parking lot where all cars are slowly moving towards the exit at once. This situation is similar to a rip current because both involve a concentrated flow of movement in a specific direction. Just as the cars funnel from a wide area into a single exit lane, a rip current forms when water from breaking waves is funneled through a narrow path from a sandbar to deeper water, creating a swift, directed flow. The use of the reflection of sound waves to locate underwater objects. Sonar. Sonar is a technology that uses sound waves to detect and locate objects underwater. Imagine trying to find your keys in a dark room by clapping your hands and listening for the sound bouncing off objects. This is similar to how sonar works, where sound waves are emitted underwater and their echoes are used to detect objects. Just like your clapping creates sound waves that reflect off your keys and other items to reveal their location, sonar uses the reflection of sound waves to locate underwater objects by interpreting the returning echoes. A wave that forms in shallow water and breaks on the shore. Breaker. In science, a breaker is a wave that collapses onto the shore, causing its energy to dissipate. Imagine you're carrying a tray full of drinks, and as you approach a doorway, you suddenly have to stop abruptly. Just like the drinks slosh over the rim when you halt, a wave traveling towards the shore suddenly encounters the shallower water, causing its energy to pile up and the wave to break. In both scenarios, the sudden change in conditions, like stopping at the doorway or the wave hitting shallower water, causes the contents, drinks or water, to spill over, illustrating how the energy is redistributed and results in an overflow or a breaking wave. The horizontal movement of water at or near the ocean's surface. Surface current. Surface currents are ocean waters that flow across the surface, driven primarily by wind patterns. Imagine trying to navigate a crowded mall during a big sale where everyone seems to be moving in different directions, but eventually follows certain paths. This scenario is similar to surface currents in the ocean, where water at or near the surface moves horizontally due to various forces like wind, the Earth's rotation, and temperature differences. Just as shoppers are guided by store locations and crowd movements, surface currents are directed by the interplay of these forces, creating predictable paths in the ocean that resemble the flow of people through a bustling mall. The vertical movement of cold water from the deep ocean to the surface. Upwelling. It is a process where deep, nutrient-rich water rises to the ocean's surface, supporting marine life. Imagine being in a crowded room where the air feels stuffy, and opening a window allows fresh, cooler air to circulate and refresh the space. This is similar to the ocean's process of upwelling, where cold, nutrient-rich water from the deep ocean rises to the surface, rejuvenating the marine environment. Just like how opening a window brings in fresh air to replace the stale, warmer air, upwelling brings essential nutrients from the ocean depths, invigorating marine life and promoting biodiversity at the surface. A repeating disturbance that transfers energy through matter or space. Wave. In simple terms, a wave is a way energy moves from one place to another, like how ocean waves travel across the sea. Imagine trying to pass a message across a crowded room without moving from your spot. Just as you would need to rely on a series of people repeating your message until it reaches the intended recipient, a wave transfers energy through a medium by passing it along from one particle to the next. In this analogy, each person represents a particle in the medium. The message is the energy, and the act of passing the message along is akin to the disturbance that travels through the medium, illustrating how waves transfer energy across distances. An area where fresh river water mixes with salty ocean water. Estuary. An estuary is where rivers meet the sea, creating a unique and productive environment for many species. Imagine trying to blend two different playlists, one filled with soothing acoustic tracks and the other with high-energy dance music, into a single cohesive party mix. Just like the challenge of merging these contrasting music styles into a harmonious blend, an estuary is where fresh river water and salty ocean water meet and mix together. In this analogy, the soothing acoustic tracks represent the calm, fresh river water, while the energetic dance music symbolizes the dynamic, salty ocean water. The result is a unique and balanced environment, much like the diverse ecosystem created in an estuary where these waters converge. A large, flat area of the deep ocean floor, abyssal plain. An abyssal plain is a vast, flat region on the ocean floor, several kilometers deep, where sediment covers uneven seabed rock. Imagine trying to find your way through a vast, crowded parking lot after a concert, where every row and section looks identical, making it difficult to locate your car. This scenario is similar to the abyssal plain, a large, flat area of the deep ocean floor that stretches for miles without any noticeable landmarks or variations. Just as a parking lot extends flatly in all directions, making it hard to discern one area from another, the abyssal plain is an expansive, featureless region that can be challenging to navigate due to its uniformity and vastness. A part of the ocean floor that dips steeply down from the continental shelf. Continental slope. The continental slope is the area where the ocean floor quickly drops in depth after the shallower continental shelf. Imagine you're at a swimming pool and you're walking from the shallow end towards the deep end, where the bottom suddenly drops off steeply. This abrupt change in depth is like the continental slope, which marks the transition from the gradually descending continental shelf to the much deeper ocean floor. Just as you experience a sudden, steep decline in the pool, the ocean floor also undergoes a steep drop at the continental slope, indicating a shift from the shallow waters of the continental shelf to the deep abyssal plains of the ocean. A long mountain range on the seafloor, formed by lava eruptions through Earth's crust, mid-ocean ridge. It is where tectonic plates move apart, allowing magma to rise and create new seafloor. Imagine you're trying to bake a loaf of bread, and as it rises, the dough splits in the middle, revealing a stretch of raw dough as it expands. Similarly, a mid-ocean ridge forms when molten rock from beneath the Earth's crust pushes upward, causing the seafloor to spread apart and create a mountain range. Just as the dough surfaces and stretches apart to reveal the soft interior, the Earth's crust splits and allows lava to emerge and solidify, forming new oceanic crust at the mid-ocean ridge. The effect of Earth's rotation on the direction of winds and current Coriolis effect. The Coriolis effect makes moving air and water turn and twist, causing winds in the northern hemisphere to deflect to the right and in the southern hemisphere to the left. Imagine you're trying to walk in a straight line on a spinning carousel, just like how you find yourself unintentionally veering off course due to the spinning platform beneath you. The Coriolis effect causes winds and ocean currents to curve as they move across the spinning Earth. In this analogy, the carousel represents the rotating Earth. Your intended straight path mirrors the intended straight line movement of winds and currents. And the unexpected curve in your path illustrates how Earth's rotation diverts these natural flows, creating the Coriolis effect. Organisms that live on or near the ocean floor. Benthos. Benthos refers to living things that reside on or close to the seabed. Have you ever tried finding your misplaced keys hidden among all the clutter on your desk? Just like your keys, benthos are organisms that can be hard to spot as they live on or near the ocean floor, often camouflaged among rocks, sand, and seaweed. Just as you sift through papers and pens to find your keys, scientists explore the ocean floor to discover these hidden organisms, both requiring patience and attention to detail to uncover what lies beneath the surface. A marine organism that can actively swim as opposed to those moved by the current. Nekton. Nekton are animals like fish and squid that swim actively in the water, able to move independently of currents. Imagine trying to navigate a crowded sidewalk where everyone is moving in different directions. Just like you choose to weave through the crowd by actively deciding your path and speed, nekton are marine organisms that can swim independently of the ocean currents, determining their own direction and pace. In this analogy, you are like the nekton, exercising control over your movement, while the passive pedestrians represent plankton, which drift wherever the crowd or currents take them. Tiny microscopic organisms that float or drift in water. Plankton. Plankton are small creatures in water that form the base of the aquatic food chain, providing food for many marine animals. Imagine you're stuck in a crowded elevator, unable to move freely, just going where it takes you. This situation is similar to how plankton, tiny microscopic organisms, float or drift in water, carried by currents without control over their movement. Just as you are at the mercy of the elevator's path and the crowd around you, plankton are dependent on water currents to dictate their journey, emphasizing their passive role in their environment. A deep part of the seafloor where a subducting slab bends down. Ocean trench. An ocean trench is a deep, narrow valley in the ocean floor, formed where one tectonic plate slides beneath another. Imagine trying to fit a thick blanket into a small, overstuffed closet where you have to push it down into any available space. This is similar to how an ocean trench forms, where one tectonic plate is forced beneath another and bends downward into the Earth's mantle. Just like the blanket being pushed into a cramped space, the ocean trench represents the area where the subducting slab bends down, accommodating the pressure and constraints of the tectonic plates above and below. A worldwide climate change caused by an increase in the Pacific Ocean's temperature. El Niño. El Niño is a natural climate pattern where warmer than average sea surface temperatures occur in the Pacific Ocean, affecting global weather. Imagine you're at a party and someone accidentally turns up the thermostat, causing the entire room to heat up. Just as the rising temperature in that room affects everyone inside, making them uncomfortable and sweaty, an increase in the Pacific Ocean's temperature during El Niño affects weather patterns across the globe. In this analogy, the thermostat represents the ocean's temperature, and the room's uncomfortable guests symbolize the worldwide climate changes triggered by El Niño. A worldwide climate change caused by a decrease in the Pacific Ocean's temperature. La Niña. La Niña is a climate pattern where the sea surface temperatures in the central and eastern Pacific Ocean become cooler than average, impacting global weather patterns. Imagine you're in a room where someone suddenly turns the air conditioning way down, making it uncomfortably cold. This drop in temperature not only affects how you feel, but also changes the dynamics in the room, like causing people to huddle together for warmth, or even make different choices about where to sit. Similarly, La Niña involves a decrease in the Pacific Ocean's temperature, which, like the air conditioning, leads to wide-reaching effects on global weather patterns, causing shifts in atmospheric behavior, just as the cold air causes shifts in how people behave in the room. A tide with the greatest range between high and low tides, spring tide. A spring tide occurs when the Earth, Moon, and Sun are aligned, causing higher high tides and lower low tides. Imagine you're trying to manage your week, with both work deadlines and social events piling up at the same time. Just as this combination creates the most hectic and demanding days for you, A spring tide occurs when the gravitational forces of both the moon and the sun align, pulling the ocean's water in the same direction and creating the highest high tides and lowest low tides. In this analogy, your work deadlines and social events represent the gravitational pulls of the sun and moon, and the resulting busy schedule is like the extreme tidal range of a spring tide. The tide with the smallest difference between high and low tide. Neap tide. Neap tide occurs when the gravitational forces of the moon and sun are perpendicular, causing less variation in tidal heights. Imagine trying to wash your car when the water pressure in your hose is at its weakest. Just like how the water pressure feels low and doesn't make much of a splash, a neap tide is when the gravitational pull of the moon and the sun are not aligned, resulting in the smallest difference between high and low tide. In this analogy, the weak water pressure is like the minimal gravitational forces from the moon and sun not working together, leading to the less dramatic rise and fall of the tides, much like the subtle flow of water from your hose. A huge wave caused by an underwater earthquake. Tsunami. A tsunami is a series of large ocean waves created by the displacement of water, often due to underwater earthquakes. Imagine you're carrying a tray full of water glasses, and you suddenly trip over a small bump in the floor. Just like the water in the glasses might spill over the edge due to the sudden jolt, a tsunami occurs when an underwater earthquake displaces a large amount of water. The bump represents the seismic shift beneath the ocean floor. The tray is akin to the ocean surface, and the spilling water mirrors the massive ocean wave that spreads outwards from the disturbance, creating a tsunami. The shoreline between high and low tide. Intertidal zone. The intertidal zone is the area of the beach that is covered by water at high tide and exposed to air at low tide. Imagine trying to keep your feet dry while walking along a beach, where waves constantly shift the boundary between dry sand and wet sand. This challenge is similar to the ever-changing intertidal zone, the shoreline that shifts with the tides. Just as you navigate between the wet and dry areas of the beach, organisms in the intertidal zone must adapt to both aquatic and terrestrial conditions as the tides ebb and flow, creating a dynamic environment that changes with the rhythm of the ocean. The farming of water organisms like fish aquaculture. Aquaculture is the process of raising fish and other aquatic animals in controlled environments for food and other products. Imagine trying to maintain a small backyard garden where you must ensure the right balance of sunlight, water, and nutrients for your plants to thrive. This is quite similar to aquaculture, where farmers manage and control the environment of water organisms like fish to ensure they grow healthily and efficiently. Just as gardeners must monitor soil quality, water levels, and plant health to produce a bountiful harvest, aquaculture farmers carefully regulate water conditions, feed, and health of the organisms, ensuring a sustainable and productive aquatic crop. A diverse marine ecosystem made of coral fragments. Coral reef. A coral reef is an underwater structure made from the skeletons of tiny sea animals called corals, providing habitat for many marine species. Imagine trying to fit together a 1,000-piece jigsaw puzzle without a picture on the box. Just like each piece of the puzzle is unique and essential to complete the whole image, a coral reef is composed of countless individual coral fragments, each playing a vital role in forming the larger marine ecosystem. In this analogy, each puzzle piece represents a coral fragment, and just as every piece is necessary to finalize the puzzle, every coral fragment is crucial in building and maintaining the diverse and interconnected structure of a coral reef.